So this talk is basically about a specific issue we were facing in packaging OCaml packages in Debian. So the work is by me, by Sylvain, Mehdi, and Stefano. And so the main problem we wanted to face is that, okay, we all know about inconsistent assumptions when compiling OCaml code. So our problem as maintainers of Debian packages about that is that we really want that when you face an inconsistent assumption error, the programmer should be sure that it is his own fault. So it should not be the case that there are a couple of Debian packages installed which ships like a couple of OCaml libraries which have not been compiled in the proper order, or maybe one of them is out of date. And so you should be sure that the error is your own and there is no like mismatch in compilation of OCaml libraries. This was not the case since the last, actually no stable release of Debian has ever enjoyed these properties thus far, but it will be part of the next Debian release, and I think it is already part of the Ubuntu Lucid release, which is coming up in 2 weeks. So the reason why we have this problem and people like packaging C library as have not, is that there is some kind of differences between linking in C-like languages and in OCaml-like languages. And the main problem is that when you link like C code, you basically have just a very simple checks. You basically just check a form of referential integrity. So you have a set of objects you are compiling, which refer to some external symbol, and the linker just check if the object you are requiring are there. And this, in addition to some kind of discipline, which in theory guarantees that at each release of C library you just add symbols, and in theory you do not remove old symbols, gives some sort of de facto backward or forward compatibility. What? Ah, I need to stay here. Yeah. Okay. So I can't promise that because I walk around every... I'm sorry. So basically in C, packagers are used to the idea that a future version of a library will not remove any symbol. So you will not have any kind of linking problem due to a removed symbol, in theory. And so the usual dependency scheme for C libraries is something like this. So you just depend on some library, and you usually say that you depend on a version of a library greater than a specific version. Because you implicitly assume that future version of the library will not make anything which will inhibit the linking with that specific library. So this is a rather simple versioning scheme for C-like libraries, but it does not work for OCaml. So, in fact, I'm sure we all face this kind of pain when compiling, at least by hand, OCaml libraries. The OCaml linker is way more strict, hopefully, and luckily for all of us, because it really checks if you have some, if you ever expected the assumption that all objects you are compiling together have made when they were compiled. So when you compile a specific object, like a simple OCaml module, inside the module there are some checksums, which tells the specific checksum, the specific hash sum of all external module you are using. So for instance, if you just build a module called foo, you can look with the OCaml obj info at all the assumptions it made on external module and also on its interface. So if you try to change something, you will get the very famous inconsistent assumption error, which basically means you don't have any kind of backward compatibility when you change, forward compatibility actually, when you change a library. So this is the very simple example. You have a main.ml file, you build it, you change, you build it like just as an object, and then you build it against an external module called foo. If you change the module foo by adding a new function, which in theory is a completely innocuous change, well, when you try to link the object together, you will get an inconsistent assumption error because the interface of foo, which has been registered in main CMO, changed over time. So the point is that how can we, as a package maintainer, ensure that if you are able to install two different packages, one shipping main and one shipping foo, this step of linking will complete properly. This is the actual question that we need to face. So the plan for the rest of the talk is that I will just give some highlights on our packaging needs and how our packaging workflows goes. And then I will say the requirements that we put forward for a proper system. And then I will present our solution to the problem, which is called ABI approximation. So Well, my Debian package, but actually all kind of packages in binary distribution is a distinction between source packages and binary packages. So a source package is usually just the tarball that the software developer prepare with the OCaml library or with the OCaml application, plus some metadata, plus some specific build instruction that we use in distributions. When you compile a source package, you get several binary packages with different features. For instance, a common example can be the OCaml.net library, which is a very famous OCaml library. When we compile it, we obtain several different binary packages, like libOCaml.net, OCaml.dev, or an Apache module, which to load OCaml code in Apache, and all this kind of stuff, documentation packages, whatever. So a binary package has some metadata as well. So in particular, it has a lot of fields which declare inter-package relationships. So the very common are depends, provides, and conflicts. Depends is straightforward. It tells the other package you need. Conflicts, the package you cannot be installed together. And provides a kind of an abstraction layer which tells you which feature you are providing so that other package can refer to them. So these are packages. What is the workflow we maintainer apply to packages and to the development of packages? Well, we usually upload to the distribution archive, in our case to the Debian archive, a pair of a pair where we upload a source package and a specific compilation of it. So all of its binary packages built like on our machine we use to do development. So we upload them to incoming, and then the package goes through several steps. This is specific to Debian, but other distribution has similar workflows. So we upload it to Unstable. After some time, if all goes well, it will end up in testing. And when we release, it will end up in stable. This happens, as you have noticed, like every 2 years, if you're lucky. So this is the basic workflow. But we also have an additional and specific workflow to just rebuild packages, which in Debian is called binary NMUs, and in other distribution, just rebuild. So we can ask the system to just rebuild a source package which is already in the archive. So for instance, if the OCaml compiler changes and we don't need to do any specific change to a given source package, like our OCaml library, we can just ask the system to rebuild the old library with the new version of the OCaml compiler. And this actually happens also not for specific request of the maintainer, but also on all different architectures. For instance, my laptop is just an Intel-based laptop. In Debian, we support 10 different architectures. And when I upload the package, it also gets rebuilt on all the other architectures thanks to the so-called build daemon infrastructure. So a third ingredient, which is important to what we need, is so-called dependency inference, which has nothing to do with type inference. It's way more simple. It is just a way to make our lives of package maintainer easier. So in the source package, I really don't want to specify all dependencies of my packages, because most of them can be computed at build time. So for instance, if you look at the binary application like MLDonkey, you just specify some specific dependency which you know are used around time. And then you have some kind of variables like this, shared libraries depends and miscellaneous depends. And during package build, these two variables are expanded by some means and get expanded to blobs like this one. So the shared library depends are all the dependencies which can be inferred by looking at ELF objects. And so looking at the ELF objects and their dependency, you will get this kind of blob, which is very, very handy to not have to maintain by hand, because it is very error prone. So, having said that, what are the requirements we want for our scheme for versioning OCaml applications and libraries? The first requirement we want is what we call dependency soundness. So we want that each package that has dependency soundness, that has sound dependencies, and a priori we want all packages to have sound dependencies, is such that if you can install it, you can then link all its objects without having any kind of link time error. So this is what was missing thus far, and this is what we have now. So this is what really gives you the property that if you find an inconsistent assumption error, then it is your fault. The second requirement we want for to have our life acceptable in our work is that we want dependency inference. So we really don't want to maintain by hand the list of dependencies over other OCaml libraries. So we really want to write something like this in all OCaml-based packages, OCaml depends, and we want that variable to be expanded on the fly for us. The third requirement is that we want so-called bin and MEU safety. So it is quite painful for us to do transition from one OCaml version to another, because we have like hundreds of OCaml packages now, and we really cannot upload all of them by hand each time a new OCaml compiler comes out, because we are just not even 10 active people, so we really don't have the manpower to do that. So what we really want is that we upload a source package only when it is really needed. For instance, if there is a non-backward compatible change in OCaml compiler and we need to do some kind of porting. But in all other cases, we really want to just trigger automatic rebuilds of all the source packages which are already in the archive and get them rebuilt and be done with that. And of course, doing that should not make the dependencies of packages unsound. The final requirements is that we want the battery. So hello? Yes. So the final requirements is that we want metadata of packages to still be like readable by humans. So what you see in this slide is the dependency scheme which were used in Red Hat and Fedora, I think thus far. I have no idea if they've changed. So what they did is basically to put in every OCaml related package a list of virtual packages, if you want, corresponding to all assumptions made between OCaml objects. So for instance, the OCamlNet package in Fedora used to have this kind of dependencies with like 70 virtual packages provided, one for each assumption on one for each interface exported by object shipped by the package. And the same goes for dependency. So sorry, this is the provided features, this is the dependencies on external packages. So this is okay, this gives you soundness, but it makes the dependency of a package completely unmanageable by humans. So in Debian, this was a problem because we have a process of transitions between the testing distribution and between the unstable distribution and the testing distribution. And at that point, there are people which will look at dependency to understand why a package cannot be migrated from one suite to the other. And in that case, having this kind of dependency were completely unacceptable for the Debian release team. So what we want is that no matter how we implement the previous three requirements, the metadata of the package still remains readable by humans. Ideally, should be just a single dependency and grasping all the details. So to achieve this, we basically have found a solution which we call ABI approximation. So the idea is that we take a big hash of all interfaces which are exported by a given OCaml package. So if an OCaml library ships like 10 OCaml objects, what we do is that we check for all the exported interface of these modules. We take a big hash of all of them, and we make a single provide field with that hash. And we do the same for dependencies. So we look at all the external interfaces which are needed to link these objects. We look them up somewhere. And from that, we can find the appropriate dependency. That somewhere is a registry where we basically store all the information of installed libraries on your package. So when you install an OCaml library, you have a registry which gets built bit by bit, which states, okay, this package is just installed, provides this specific hash, so that if you are trying to build another package which would need that hash, you will know which package provided on your system. So this actually gives all we need. And from the packaging side, we have a tool called OCaml, which does all the machinery of adding the appropriate dependencies. And also a tool called OCaml MD5 sums, which is basically the handler for the local registry of checksums on your system. This is an example of how we work now with OCaml source packages. So each OCaml library has a variable called OCaml provides, which is just this syntax, and the same for dependencies. And during package build, the two get expanded. So for instance, for the OCaml.net package, actually the main part of the OCaml.net package, we will have a lib-OCaml.net OCaml.dev dash a small hash, which are five ASCII characters. And this hash grasps all the information offered to external library by the OCaml package. And the same goes for OCaml depends. So what is happening there is that during package build, actually at the end of package build, all shipped objects of OCaml.net are inspected, and the registry of checksums is consulted basically, and we find out that this library depends of libcrypt.gps on its runtime part on PCRE and on a specific version of the OCaml compiler. So of course there are a risk of collision, but we made some computation that we have a really low chance of collision with up to 1,000 versions for each involved packages. So, concluding, this is a scheme comparing the solution we are aware of in various distributions to face this kind of problems. So the past Debian status quo was simply to use C-like dependencies. So when we depended on an external library, we just put, okay, let's use that version of the current version of the library or a greater version. And that, of course, does not give you soundness, so it was a no-go for us. Then we added on top of it some kind of dependency inference, but still keeping the same versioning scheme. So it was not really helping. Then there are the current Fedora guidelines, which is the one I show you with all explicit depends and provides on all module checksum. Well, this is quite kind of okay, up to the fact that they only look at the assumption between bytecode objects, while we now have tools developed by Stefano and Mehdi, all of three of them, and which can inspect the assumptions also of native code objects and also of the new CMXS objects. So they kind of provided inference only up to bytecode objects, but they were totally non-manageable and non-acceptable, at least according to Debian release processes. And we now have a final solution which is called approximation, which actually implements all our needs. So there are some limitations. Well, there are some technical limitations about architecture-independent packages, which I won't you bother with. But what is most interesting is that we miss a way to inspect the assumption, let's say, of C stubs. So it is interesting to know that when you write a C stubs for OCaml code, well, that code makes some assumptions on specific OCaml types. But that assumptions are only encoded in the C stub itself. There is no way to inspect them. So an idea we would like to try out is actually to to add to the OCaml, to the C macros used to write C stubs, some way to dump the type information they entail, so that we can inspect them from the outside and actually do the same kind of soundness checking for C stubs packages. So, in the forthcoming Debian squeeze, we will have about some numbers. We are about 150 OCaml source packages for more than 350 OCaml binary packages. We ship in total 2,500 OCaml modules, and hopefully we will give you zero inconsistent assumptions. So, if you want to join us, well, you are more than welcome. Manpower is always something we need. This is the mailing list, which is our main contact point. If you use OCaml on Debian or any derivatives, including Ubuntu, you should think about helping us. And I'm open for all questions you may have. Thank you.
I might have missed this, but if you want to... Suppose you actually want to release a new library that has the same ABI but is semantically incompatible. So in C you would just bump the version number. Is there some way you can put something else into this hash to cause it to
So it is not managed by the system, but you should do that by hand basically, because the fact that the semantic has been changed is not something that can be inspected. So you usually do that by the usual way. You do a explicit provide and explicit depends on that provide.
Okay, yeah. So you sort of put the extra version number only in the metadata.
Yeah, it's yeah, absolutely. So it's kind of orthogonal with this.
Okay, and how does this work? Presumably, your system needs to have this map of hashes to like long hashes somewhere.
Yes.
So what happens if you delete that by accident? Does it get recreated by, is there just one of these, or does it like get added to by?
So the way it works is that each binary package contributes a small file to the global registry, and the global registry is basically a cut of all the files together. So actually, we don't have any redundancy, but I mean.
But you could repull this from a server somewhere if you needed to.
So no, we don't have any redundancy, but I mean it is stuff provided by each binary package. So in principle, you can always reinstall the package because it is completely static stuff, and you will get a pristine registry back.
Okay.
Obviously, in Fedora, we're still using OCaml obj.info, which has a number of shortcomings I'm sure you found. And you mentioned that you've written some other tools. Are you going to release those?
So they have been released. I think they are in the OCaml BTS, right? Not yet, not yet. But they are available in in our tool, and we still use OCaml obj.info, but we also have additional tools to query the other kind of objects. So there are three actually. One is OCaml dump approx for CMXS, and one is OCaml native info for the other kind of native objects.
Well, just a plug. So if you guys are interested in joining forces to write really good OCaml dumper utility, that would go immediately in our release. Thank you.
So I have a plug on this too. What is interesting in Debian is that the Haskell maintainer had exactly the same problem, and after looking at our solution, has implemented something isomorphic for Haskell packages. So I don't know the details of how and where they have assumption external models, but they have the same problem. They implemented the very same solution. Okay, thank you.